Python 3 more types. The none object is used to represent the absence of a value. It is similar to null in other programming languages. Like other empty values such as 0, an empty list, and the empty string, it is false when converted to a Boolean variable. When entered at the Python console, it is displayed as the empty string. So at the first insertion point, we have none double equals none, and when you hit enter, the output for that is true. At the next insertion point, we just put none. At the third insertion point, we have print, and in parentheses none. And if you hit the enter key, you will get none as the output. And next, what is none often used to represent? An absence of value. The none object is returned by any function that doesn't explicitly return anything else. For example, def sum underscore func, empty parentheses, colon, print, parentheses, the string hi. Outside of that function, we have var equals sum underscore func, empty parentheses. So we're calling sum func, and we're putting the value of it in a variable called var. And then we use the print command to output the value of var. So print parentheses var. Your result will be on the first line hi, and then after that none. What number does this code print? Foo equals print empty parentheses. So on the right hand side of the assignment equals, you see print empty parentheses. It's basically printing nothing and putting that value in the variable called foo. If foo is equal to none, then print 1, else print 2. Dictionaries. Dictionaries are data structures used to map arbitrary keys to values. Lists can be thought of as dictionaries with integer keys within a certain range. Dictionaries can be indexed in the same way as lists, using square brackets containing keys. For example, ages equals, and then in our curly brackets we are creating a dictionary. And we have the string Dave, colon 24, comma the string Mary, colon 42, comma the string John, colon 58. So there's a dictionary, key value pairs, and the dictionary's name is ages. Then we have a couple of commands, print, parentheses, ages, which is the name of the dictionary. And then in the square brackets, we have Dave, which is the key. 24 is the value. Lastly, we have print parentheses again, the name of the dictionary, which is ages, and in the square brackets, we have one of the keys. In this case, they're putting the string Mary. The value to the Mary key is 42. So when you look down further and you see the results, you see 24 on the first line and 42 on the next. Each element in a dictionary is represented by a key, colon, value pair. Fill in the blanks to define a valid dictionary with two elements. So the name of the dictionary is cars. We use the single equals to assign something to cars, and we put all this good stuff in curly braces. So we have curly brace, the string BMW, then you have to use a colon, and then the string blue. So BMW is the key, and the value that belongs to BMW is blue. We now want to put a comma here to separate the next key value pair, which is the key is Volvo, then there's a colon, and the value for Volvo is red. And then you close all this up with a closing curly brace. Trying to index a key that isn't part of the dictionary returns a key error. For example, here we've got a dictionary called primary. So you have primary on the left-hand side of the equal, and on the right-hand side, you've got all of these key value pairs enclosed in curly braces. Red is the key, colon, and then we've got a list here enclosed in straight brackets, 255, comma, 0, comma, 0. And outside of the straight brackets, we have a comma. And it's going to separate our next key value pair, which is the string green, followed by a colon, followed by a list enclosed in square brackets, 0, comma, 255, comma, 0. Outside of that key value pair, we have another comma because we have a third key value pair. The last key value pair is the key is blue, the string blue, followed by a colon, followed by the list, 0, comma, 0, comma, 255, enclosed in square brackets. There is another comma outside of this third key value pair before we close up the entire dictionary with a closing curly brace. Outside of the dictionary creation, we use the print command. Inside of the parentheses, we use the name of the dictionary, which is primary, and we're going to pull a key out. And in this case, we are going to pull red. The key is red. And if you look down to the result, you see the value. When the key is red, you see the value. The key is on the left-hand side of the colon, and the value is on the right-hand side of the colon. So we have 255, comma, 0, comma, 0 enclosed in the lists straight brackets. The second print command says print, parentheses, primary, which again is the name of the dictionary. We're going to pull out another key. In this case, we're going to pull out yellow. Well, if you look back up to the original dictionary creation, we only created it with red, green, and blue keys. We didn't create it with a yellow key. So when you try to access something with a key that isn't part of the dictionary, then you see key error, colon, yellow, and yellow is the key in question, and is enclosed in single quotes there. So as you can see, a dictionary can store any types of data as values. In this case, it was a list. An empty dictionary is defined as just empty curly braces. What is the result of this code? Test equals empty curly braces. So we've created an empty dictionary with the name of test. Then we're going to use the print command, print, parentheses, test, which is the name of the dictionary. And in the square brackets, we have 0, which is supposedly looking for the first list item, the first element in the dictionary. Well, there is none. So I believe what we will get is none for the value. And we're wrong. Let's try key error. No. Yeah, it is key error. And it's key error because it's looking for a key that isn't there. So that was my mistake. It's looking for the key of 0, and there is no key of 0. So, alrighty. Only immutable objects can be used as keys to dictionaries. Immutable objects are those that can't be changed. So far, the only mutable objects you've come across are lists and dictionaries. Trying to use a mutable object as a dictionary key causes a type error. So here we have the dictionary called bad_dict equals, and then in the curly braces we have one key value pair. Here they have the key as a list with 1, 2, and 3 inside, then a colon, and then they gave the value to that key, the string 1 space 2 space 3. Well, only immutable objects, which are things that can't be changed, are allowed to be keys. So if you try to make a list, which is something that's changeable, a key to a dictionary, the result is type error, colon, unhashable type, colon, list. Which of these values can't be used as a dictionary key? All right, we have false, we have another dictionary, and we have the string 1, 2, 3. I'm going to say that you can't use another dictionary as a dictionary key. There we go. Now let's look at dictionary functions. Just like lists, dictionary keys can be assigned to different values. However, unlike lists, a new dictionary key can also be assigned a value, not just ones that already exist. So let's look at this. Here we have a dictionary called squares, and we have it set equal to 1:1, 2:4, 3: the string error, 4:16, and all that's enclosed in curly braces. Then we use the name of the dictionary, which is squares, and we are going to have in straight brackets 8 equals 64. Well, we don't have a key of 8. We don't have a key of 8. The next one is squares, straight brackets 3 equals 9. We do actually have squares 3 because the 3 key is set to the value of error. And then finally we have print parentheses the name of the dictionary, squares. Okay, so squares 8 equals 64. There is no 8 to be set, but it looks like when we print out the value of the dictionary, it added the key 8:64. The key is 8, the value is 64. So it added it to the beginning of our dictionary. So then we have 8:64, which is the new thing we added. Then we have 1:1, which was the original first one in the dictionary. Then we have 2:4, which was the next one in line. We have 3:9 instead of 3:error because we gave the key of 3 a new value. We replaced the string error with the number 9. So that's why 3:9 is the next key value pair in the result. And then the very last one is the 4:16. That didn't change at all. So that's how that one went. What is the result of this code? The dictionary called primes is set equal to, in curly braces, the key 1 is given the value of 2, the key 2 is given the value of 3, the key 4 is given the value of 7, and the key 7 is given the value of 17. Then we're going to use the print command, and in parentheses we put the name of the dictionary, which is primes, and then in the square brackets we have the name of the dictionary again, which is primes, and in the straight brackets we have the key 4. So when you have multiple nested statements like we do here, you're going to look at the innermost nest. What is the deepest nested thing here? And the deepest nest is primes, straight brackets 4. So if you look at primes with the key of 4, you have the value of 7. So now if you can just imagine primes square brackets 4 is gone and it's replaced with a 7, now we're working out, we're bubbling out now to the first primes, and it will be primes with square brackets of 7. So now it's primes key 7, and if you look in the primes definition, the key 7 has a value of 17. So what you're going to do is you're going to go bubble out a little more where you have actually the print command, and inside of the parentheses we've established that the value is 17. So we're going to print 17. There we go. To determine whether a key is in a dictionary, you can use in and not in just as you can for a list. For example, we have the dictionary here called nums. So on the left-hand side of the assignment equals, we have the name nums. And on the right-hand side, we have the dictionary in the curly braces. We have the key of 1, followed by a colon, and it's assigned the value of 1, which is a string. After the comma, we have another key value pair here. The key is 2, colon, the value is the word 2, comma. Then we have another key value pair. We have the key 3, colon, and the value, the word 3. And then another comma after that one, and then the closing dictionary curly brace. Then we have 3 print commands. The first print says print, and in parentheses 1 in nums. Well, we do have a key of 1 in the dictionary called nums, and it has a value of ONE. But we are using in and not in, not to give us the value, but to let us know if it exists. So our first result line is just the word true. We're not looking for the value. We just want to see if the key is actually in there, and it is. The second print command is print, parentheses, the string 3 in nums. Okay, there is no string 3 as a key in nums. We have the number 1, the number 2, and the number 3 as keys, but we do not have the string 3 as a key. We have the string 3 as a value because it's on the right-hand side of the colon. So the second line of output is false. Lastly, we have print, parentheses 4, not in nums. Well, we actually don't have the number 4 as a key in that dictionary. So 4 not in nums is a true statement because 4 is not in nums. 4 is not a key in nums. Okay, drag and drop from the options below to print yes if the key 112 is present in the dictionary named pairs. So if 112 in pairs, print yes. So if 112 is in the dictionary name pairs, colon, print the string yes. A useful dictionary method is get. It does the same thing as indexing, but if the key is not found in the dictionary, it returns another specified value instead. None is by default. For example, here we have a dictionary with a name of pairs, and it is set equal to, in curly braces, the key 1, colon, the value apple, comma, the key, the string orange, colon, the value, this list that has 2, 3, and 4 inside, comma, the key true, colon, the value false, comma, and lastly the key none, colon, the value, the string true, comma, and then you close up the curly brace, and then we have 3 print commands. Print, parentheses, the name of the dictionary, which is pairs, and then we're going to use a method here, a dictionary method, by using the dot operator and the method's name, which is get. So pairs.get, parentheses, the string orange. If you look down into the result, if you look for the key called orange, and then you look for what's on the right-hand side of the colon, you see the list 2, 3, 4. So that's the first line of output. If you go back up and look at the second print command, we have print, parentheses, pairs.get, parentheses 7. Well, we're looking for the keys. So do we have a key of a number 7? No, we don't. We have a key of 1. We have a key that's the name orange. We have a key of true. And we have a key of none, but we do not have a key of 7. So if you go down to the result and you see the output for the second line there, it's none. Because if we do not find the key in the dictionary by using the .get method, the output will be none by default. All right. The last print command is print, parentheses, pairs.get, And in parentheses here we have 1, 2, 3, 4, 5. Well, we do not have a key of 1, 2, 3, 4, 5, but this example is showing you that when you provide a value for something that doesn't exist by using a comma, and then here it says not in dictionary, the string not in dictionary, then you won't get the output of the word none. You'll get the output of this string, or whatever string you want, instead of the word none. So down here, the very last line of result, you see the string not in dictionary. So you can make your output specific if you don't find the key. Okay, what is the result of this code? We have a dictionary called fib, and we have it set to key 1 with a value of 1, comma key 2 with a value of 1, comma key 3 with a value of 2, comma key 4 with a value of 3. Then we're going to use the print command, and in parentheses we have fib.get parentheses 4 comma 0. Now remember, by using the .get method for these dictionaries, you're looking for the key of 4, which there is the key of 4, and the value is 3, but here they're giving you something else to output, which is 0. Wait. Actually, I believe the only reason we would use that 0 value is if 4 was not inside of the, was not a key inside of the dictionary. So the value of 4, because it is actually in there, should still be 3. So for that fib.get parentheses 4 comma 0, our value should be 3, because the key is 4. It's 4 colon 3, means the key of 4 has the value of 3. So I'm going to say that's 3. Then on the plus side, we're going to do the same thing with fib.get parentheses 7 comma 5. Fib.get parentheses 7 comma 5 means you look for the key of 7. There is no key of 7. So because there is no key of 7, we are going to make the output a number 5. So because we're adding these two values, 3 on the left of the plus sign and 5 on the right of the plus sign, our output by using the print command should be a number 8. And it is. Okay, let's look at tuples. Tuples are very similar to lists. And I'm not sure if I'm saying that right. It might be tuples, but I'm calling it tuples. But they're very similar to lists, except that they are immutable. So there's that immutable word again. They cannot be changed. You can change a list item, but you cannot change a tuple. So also they're created using parentheses rather than square brackets. So now we've got 3 different syntaxes here. For a dictionary creation, we use the curly brace. For a list, we use straight brackets. And for tuples, we use parentheses. You can access the values in the tuple with their index, just as you did with lists. So lists and tuples use indexes, whereas dictionaries use keys. So if you can just remember that, if you can identify that you're looking at a tuple, a list, or a dictionary, and then remember where you use indexes and where you use keys, then you should understand what your output's going to be. So you can access the values in the tuple with their index just as you did with the lists. Here we have the print command, and in parentheses we have the name of the tuple, which is words. And in this case we have in square brackets 0. So we want the tuple that has the index of 0, which in this case is the string spam. Okay, trying to reassign a value in a tuple will cause a type error because we just determined that tuples cannot be changed. So when you have words, which is the name of the tuple, and then in straight brackets we have 1 equals cheese. what we're trying to do here is we are trying to reassign words index 1 that was originally the string eggs to now cheese. This is our error. Type error, tuple object does not support item assignment. So these little rules for each of these things we're learning about, whether it's a dictionary, a list, or a tuple, you have to memorize these rules. Like lists and dictionaries, tuples can be nested within each other. Fill in the blanks to create a list, a dictionary, and a tuple. So the first thing wants us to create a list. We have pound list, which is just a comment in our code. The list is going to use square brackets. So list equals opening square bracket, the string 1, comma the string 2, and a closing square bracket. The next one it wants us to do is a dictionary. Dictionaries use curly braces. So here we have dict equals opening curly brace, and dictionaries have key value pairs, so there's going to be something on the left of the colon and something on the right of the colon. 1 colon the string 1, comma 2 colon the string 2. And again, 1 is the key, and the string 1, the word 1, is value. The number 2 is the key, and the string 2, or the word 2, is the value. And again, we have to close it up with a curly brace. And the last thing is a tuple. They want us to create a tuple. So TP equals, and remember, tuples are created with simple, plain, ordinary, old parentheses. It cannot be changed. It's immutable. So in this tuple, we have the string of 1, comma the string of 2. Tuples can be created without the parentheses by just separating the values with commas. Okay, so here we have my underscore tuple equals the string 1, comma the string 2, comma the string 3, and we don't use the parentheses at all. We just have them listed out there like that. Now, when we use the print command and in parentheses we have the name of the tuple, which is my underscore tuple, and then in square brackets we have 0, we're still, just because we didn't use the parentheses doesn't mean we're not looking for the index. We just didn't have to use the parentheses. So my tuple, straight bracket 0, means my tuple index 0, which means the string 1. And as you look down under the result, you see the string 1 is the output. An empty tuple is created using an empty parentheses pair. Okay, so you can show your tuple that's not empty without parentheses, but if you want to create an empty tuple, you do have to use parentheses in this case. You can't just say tuple or tuple equals and then nothing. You have to indicate it with that parentheses. Tuples are faster than lists, but they cannot be changed. What is the result of this code? Tuple equals, and you have two sets of parentheses here. You have an inner one and you have an outer one. The outer parenthesis is containing the entire tuple. So you have a 1, comma, and so tuple with an index of 0 is 1. After the comma, you have a parenthesis that is another tuple, 1, comma 2, comma 3. That is tuple with the index of 1. It's that entire 1, 2, 3 tuple. So when we have the print command, print parentheses the name of the tuple, which in this case is tuple, and then square brackets 1, it wants us to print out the value for the tuple index 1, which is the 1, 2, 3 tuple. And therefore, this middle one should be right. And it is. Okay, let's look at list slices. List slices provide a more advanced way of retrieving values from a list. Basic list slicing involves indexing a list with 2 separated integers. This returns a new list containing all the values in the old list between the indices. For example, Okay, remember we're dealing with the lists here. So the name of the list is squares, and after the equals assignment we have in square brackets, again because the list uses square brackets, 0, 1, 4, 9, 16, 25, 36, 49, 64, and 81. All right, now we have 3 print commands. The first one is print parentheses squares, which is the name of the list. And then in square brackets, we have 2:6. So this is like a range, okay? It starts off with squares of index of 2, which starts with the 4. And it stops and does not include index of 6. Wait, let me make sure. 4 is 2. 9 is 3. 16 is 4, 25 is 5, and 36 is 6, but it's not included. So just like ranges, the uppermost part of the range is not included. Up to, but not including. And if you look down on the result, you see the list 4, 9, 16, 25 as the slice. Okay, the next print command says print parentheses squares straight brackets 3:8. So starting at squares index 3 all the way up to but not including squares index 8. Squares index 3 starts at 9. 3 is index 3, it has a value of 9. Index 4 has a value of 16. Index 5 has a value of 25. Index 6 has the value of 36. Index 7 has a value of 49. Index 8 is not included, so we actually stop at 49. So we go down to the result you see in the list is 9, 16, 25, 36, 49. The last print command says print, parentheses, the name of the list, which is squares, and then the range in the square brackets, 0:1. So we start with squares index 0, which has the value of 0, up to the range of 1, but not including 1. So, as you can see, the very last output of the result output is simply the list with only 0 inside. Like the arguments to range, the first index provided in a slice is included in the result, but the second isn't. What is the result of this code? So we have a list named SQS, short for squares, equals, and then in square brackets we have 0, 1, 4, 9, 16, 25, 36, 49, 64. Then we use the print command, and in the parentheses we have the name of the list, which is SQS, short for squares, and then in the square brackets we have 4:7, which stands for our range. It starts at squares index 4, and goes to squares index 4, squares index 5, squares index 6, and stops. Does not include squares index 7. So we're going to see 3 elements of the list, 3 list items. So squares index 4 starts with 0, 1, 2, 3, 4, 16. 16, 25, and 36 will be our output, and that's the last one down here. If the first number in a slice is omitted, it is taken to be the very start of the list. If the second number is omitted, it is taken to be the end. For example, here we have a list with the name of squares, and in the list, in the square brackets, it's 0, 1, 4, 9, 16, 25, 36, 49, 64, and 81, separated by commas. Our first print command is print, parentheses, squares, which is the name of the list. And in our square brackets, we have 7. So because it's not just print squares, square bracket 7, it's using a colon, we want to start at the very beginning of the list and go all the way up to, but not including, squares with the index of 7. Squares with the index of 7 is 0, 1, 2, 3, 4, 5, 6, 7. is the value 49. So we want to start at the beginning of the list and go all the way up to 49, but don't include 49. So that's 0 to 36. That's going to be our first output. Now if you look down here at result, you see the list, which is enclosed in square brackets, 0 through 36. Then the next print command is print parentheses squares, and in the square brackets this time we start at 7. We start at squares index 7 because we have a colon, and it's going to end at the very end of the list. They don't give you a number, so it means the end. So 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7. This is going to start at 49 and then include everything all the way to the end of the list. So we'll get 49, 64, and 81 in the second list. And as you can see, under result, you in fact have a list starting with 49, 64, and 81. Slicing, this is showing you slicing on lists, and this is saying slicing can also be done on tuples. Fill in the blanks to take the first two elements of the list. Now the first two elements of the list are going to be the name of the list with an index of 0 and the name of the list with the index of 1. So here our list is list equals the string A, the string B, the string C, the string D. A is list 0, B is list 1, but because we're using a range here, you have, after the 0, you have a colon, but we want to make sure B is included, so we don't want to say 0 colon 1 because that means the 1 is not going to be included. We want to actually put 0 colon 2. 2 is not, index 2 is not included. List 0 is A, list 1 is B, list 2 is C, and we don't care about C. So A equals list, straight brackets, 0 colon 2 will give us A and B and put it in the value of this variable called A. All right. List slices can also have a third number representing the step to include only alternate values in the slice. So we have a slice here. I'm sorry, a list, not a slice. We have a list here with the name of squares, and it is set to 0, 1, 4, 9, 16, 25, 36, 49, 64, 81 in square brackets, again because it's a list. Then we have the print command, which is going to print parentheses the name of the list, which is squares, and now in straight brackets we have colon 2, which means there's no number before the first colon, so it's starting at the very beginning. Then there's nothing after the first colon, so then it's going to go, the range is going to go from the very beginning all the way to the very end of the list. And after the second colon, we have a number 2, which represents the step. So from the first list item to the last item, we're going to do every second one. So 0, we're going to skip 1. 4, we're going to skip 9. 16, we're going to skip 25. 36, we're going to skip 49. 64, and we're going to skip 81. So when you look down at the result, you see 0, 4, 16, 36, and 64 is the slice of that list. The last print command is print parentheses squares, and in the square brackets we actually get to see all three. The first number indicates the beginning of the range, and that's squares index 2, which 0, 1, 2 starts with the number 4. And that goes all the way to, but not including, squares index 8. So we want to take it to index 7. We want to include index 7. Squares index 7 starts from squares index 2 and goes to squares index 7. 2, 0, 1, 2, 4 is 2. Index 3 is 9. Index 4 is 16. Index 5 is 25. Index 6 is 36. Index 7 is 49. We stop. So from 4 to 49 will be that list. but we're doing it in increments of 3. So we start with 4, we skip 9 and 16, and we go to 25. We skip 36 and 49. So it should just be 4 and 25. And if you look down at the result, that's actually what the output is. The list is 4, 25 in square brackets. 2:8:3 will include elements starting from the 2nd index up to the 8th with a step of 3. What is the output of this code? Okay, we're dealing with a list. The name of the list is SQS, which is short for squares, and it is equal to 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, separated by commas in our list symbol of the straight brackets. We have the print command, and in parentheses after print, we have the name of the list, which is SQS, and here's our range. In the square brackets, we have 1, so we're going to start at squares 1, which is actually the number 1 is the value. We have a colon with nothing, which means it's going to go all the way to the end of this list. So starting with 1 all the way to 81, and the second colon after which we have a 4, which is our step. So starting with 1 and going all the way to 81, we have 1, skip, skip, skip 25, skip, skip, skip 81. So we should have 1, 25, and 81 as the output. And we do. Negative values can be used in list slicing and normal list indexing. When negative values are used for the first and second values in a slice or a normal index, they count from the end of the list. Okay, so here we've got a list called squares, and it goes 1, 4, 9, 16, 25, 36, 49, 80, 64, 81. Our print command wants to print the value of the name of the list, which is squares, and here's our range in square brackets. It starts off at squares index 1, which is the number 1 value, and then there's a colon, which is followed by a -1, which means we want to go at the very end of the list as being the top uppermost range. Well, 81 is the last, is reversing it. So we're not going to include 81. We're going to go from 1 to 64, which is the second to the last. 1, 4, 9, 16, 25, 36, 49, 64. That's a little confusing, but you can get it. If a negative value is used for the step, the slice is done backwards. Okay. So using square brackets colon colon -1 as a slice is a common and idiomatic way to reverse a list. So our colon colon with no numbers before or after means the beginning of the list to the end of the list. The -1 means starting at the very last one and moving backwards. What is the output of this code? Here's the list called squares, and it said equal to 1, 4, 9, 16, 25, 36, 49, 64, 81 in square brackets separated by commas, print, parentheses, squares, and in our range, we start with square 7. Squares index 7 is 0, 1, 2, 3, 4, 5, 6, 7. It's the number 49. And it goes to squares 5, which is 25, and the -1 is the step, so this should be 49, 25. I'm sorry. 0, 1, 2, 3, 4, 5. We have 25 and 49. Oh. Okay. It's not including the starting at 7, which is 49, and ending at 5, but not up to 5. So instead of it actually going to 25, it would be 36. It's the opposite of how it would be if it weren't going backwards. So up to squares 5, but not including squares 5. Because we started with 49, 36 would be the next one in line. So 49, 36. That's the answer. There we go. Just had to think about it. Okay, list comprehensions. List comprehensions are a useful way of quickly creating lists whose contents obey a simple rule. For example, we can do the following. Here we have a note to ourselves that says a list comprehension. We have the name of cubes set equal to a list because it's in square brackets, and the comprehension part is a rule. The rule here is I asterisk asterisk 3, which means I to the power of 3 for I in range parentheses 5. Range parentheses 5 means 0 to 5. And I in range 5, let's see, how I think. Print cubes. Range 0 to 5, starting with 0 means 0 to the third power. 0 to the third power is still 0. And this is like a loop. The next thing would be 1. 1 to the third power is 1. 2 to the third power is 8. 3 to the third power is 27. And 4 to the third power is 64. So we have 5 outputs here, but we don't actually have 5 to the power of 3. So we go 0 to 5, not including 5. So it's really 0, 1, 2, 3, and 4. So when we print cubes, that's the list that we come up with there. List comprehension. List comprehensions are inspired by set builder notation in mathematics. What does this list comprehension create? Okay, the name of the list is nums, and the comprehension in the list is I times 2. That's the rule, I times 2, for I in range 10. The range I is going to be from 0 to 10, but not including 10. So it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And for each one of those list items, we are going to multiply the value of it by 2. So starting with 0, 0 times 2 is 0. And the next item would be 1. 1 times 2 is 2. The next item would be 3. 3 times 2 is 6. So you have 0, 1, 2. 2 times 2 is 4. And so on and so forth. So it should be a list of even numbers between 0 and 10. No, it's not going to be between 0 and 10 because each list item is going to be multiplied by 2. A list of all even numbers between 0 and 18, that makes sense because the range is going to be between 0 and 9. 9 times 2 is 18. It's not going to include 10. The uppermost range item, 10, it's not going to include that. It's going to go as high as 9. So this middle one is the choice I'm making, and I'm right. A list comprehension can also contain an if statement to enforce a condition on values in the list. All right, so it gets a little more complicated now. Here our list name is evens. And on the right-hand side of the equal sign, we have our list with the comprehension, which includes the if statement. So I asterisk asterisk 2, which means I to the power of 2, for I in range, parentheses 10. So our range is going to be, I is going to have the value of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, not including 10. If, plus it's going to be multiplied, it's going to have the power of 2 as well. If I to the power of 2 modulus 2 is equal to 0. So I to the power of 2 modulus 2 means if you divide that by 2, you have 0 remainder. Any number divided by 2 with 0 remainder is an even number. Okay, so print command parentheses evens. Remember, the range is 0 to 9. The first list is 0 to the power of 2, and 0 to the power of 2 is 0. 0 divided by 2, does that give you a remainder of 0? Yes, it does. There is no remainder. The next one in that range is a 1. 1 to the power of 2. 1 to the power of 2 is 1. 1 times 1 is 1. If you take 1 divided by 2, do you have 0 remainder? No, you don't. 1 divided by 2 is 0.5. That's a remainder. That's not a whole number. So it doesn't include 1. 3 to the power of 2. Wait, I'm sorry. 2 to the power of 2 is 4. And if you take 4 divided by 2, do you get 0 remainder? Yes. So that's why in our result here, the next digit is 4. The next value is 4. 3 to the power of 2. 3 times 3 is 9. 9 divided by 2 will give you a remainder. So we don't put 3. 4 to the power of 2 is 16. 16 divided by 2, do we get a 0 remainder? Yes. So 16 is the next number. 5 to the power of 2 is 5 times 5. That's 25. If 25 divided by 2 gives you no remainder, well, you will get a remainder, so that's not included. 6 to the power of 2, 6 times 6 is 36. If 36 divided by 2 gives you no remainder, which is true, it's an even number, so 36 is a value in our list. 7 to the power of 2 is 49. 49 divided by 2 does give you a remainder, so that's not included. 8 to the power of 2, 8 times 8 is 64. 64 divided by 2 will give you no remainder, and so therefore 64 is included. 9 to the power of 2, 9 times 9 is 81. 81 divided by 2, you will get a remainder, so that is not included. And that's the end of the range from 0 to 9. So that's all you get for the list: 0, 4, 16, 36, and 64. Create a list of multiples from multiples of 3 from 0 to 20. Okay, so A is going to be the name of the list, and we're going to set it equal by assignment, one single equal sign. We do want to start this list off with an opening straight bracket. There we go. For I in range 20 means, the range parentheses 20 means 0 to 19. I will have a value of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. If we're going to use an if condition, if I percent 3 double equals 0. So what that means is, whatever the number is, if you divide it by 3, you get no remainder. We want multiples of 3, so we're doing the same thing we did when we had the even numbers. It was I percent sign, which means modulo 2. Now that we're using multiples of 3, we have if I modulo 3 equals 0. So we only want numbers that are divisible by 3 evenly with no remainder. So this should be correct, and it is. Trying to create a list in a very extensive range will result in a memory error. This code shows an example where the list comprehension runs out of memory. So our list has a name of even, and it's set equal to all the stuff inside of the square brackets. That's a list. We want to create a comprehension, so we have these rules that you have to follow for the list items. So 2 times I for I in range 10 asterisk asterisk 100, which means the range goes all the way up to 10 to the 100th power. So that's a very extensive range. Because that's so extensive, the result is memory error. It won't give you anything. It will just tell you memory error. You're asking for too much. This issue is solved by generators, which are covered in the next module. Fill in the blanks to create a list of numbers multiplied by 10 in the range of 5 to 9. Okay, so we want to create a list. We're giving it a name of A. And in the square brackets, we have x times 10 for x in range 5, 9. Next, we're going to go over string formatting. So far, to combine strings and non-strings, you've converted the non-strings to strings and added them. String formatting provides a more powerful way to embed non-strings within strings. String formatting uses a strings format method to substitute a number of arguments in the string. For example, here the note is #string formatting. We have a list with a name of nums. Nums equals 4, 5, 6 in square brackets. Then we have MSG, short for message, equals the string, because it's all enclosed in double quotes, numbers, colon, and here you've got, these are like placeholders. So placeholder, I call it a placeholder. It's the curly braces 0, curly braces 1, curly braces 2. Those are 3 placeholders, 0, 1, and 2. The dot operator with the format method, dot format, and then in parentheses we have the name of the list, which is nums, and the index is 0. Nums index 0, if you look back at the creation of the nums list, nums index 0 has a value of 4, comma nums index 1 has a value of 5, comma nums index 2 has a value of 6. So the output of MSG, num 0 is going to be formatted in that 0 placeholder. Nums 1 is going to be formatted in that 1 placeholder, and nums 2 is going to be formatted in that 2 placeholder, okay? So when we have print parentheses MSG, you see the word numbers followed by a colon, followed by a 4, a 5, and a 6. Notice there's no commas or anything in between those placeholders. So we have no commas or anything in between the 4, 5, and 6. They just float right in those placeholders, the values. Each argument of the format function is placed in a string at the corresponding position, which is determined using the curly braces. What is the result of this code? Okay, this is going to be fun. Print And here you've got those placeholders, which I call them placeholders, in curly braces. And all of those placeholders are inside of your string double quotes. So you have placeholder 0, placeholder 1, placeholder 0, dot format, and in parentheses, for your placeholder 0, you have the string abra, okay? Everywhere you see placeholder 0 is going to have the string abra. And then you have a comma, and then you have, for the placeholder 1, you're going to have the string cad. So 0 has abra, 1 has cad, and 0 has abra. Abra, cad, abra. Abra, cad, abra. Abracadabra is your output. There you go. String formatting can also be done with named arguments. For example, here we have A equals, and here we have the string instead of placeholder 0 and placeholder 1, we have placeholder X and placeholder Y. So A equals in double quotes, curly braces X, comma, curly braces Y, which again, I'm calling it placeholder X and placeholder Y, dot format, and in parentheses here, you have X equals 5, comma, Y equals 2. You're going to put the 5 in there to replace the placeholder X, and you're going to put the 12 in placeholder Y to replace that. So when you have print A, you should have 5, comma, 12. And if you look down in the result, that's exactly what you got. What is the result of this code? str equals, and in the double quotes, we have a placeholder C, comma, a placeholder B, comma, a placeholder A, dot format, parentheses A equals 5, comma, B equals 9, comma, C equals 7. So remember, everywhere that you see A, you're going to plop that 5 in there. Everywhere you see the B, you're going to plop that 9 in there. And wherever you see the C, you're going to plop that 7 in there. So when we have print, parentheses str, you have to do it in the order that the str placeholders are in. Str equals CBA. Str equals 7, 9, 5. Last one. Useful functions. String functions. Python contains many useful built-in functions and methods to accomplish common tasks. We've got join, which joins a list of strings with another string as a separator. You've got replace, which replaces one substring in a string with another. You have starts with and ends with. Determine if there is a substring at the start and end of a string, respectively. To change the case of a string, you can use lower and upper. The method split is the opposite of join, turning a string with a certain separator into a list. And here's some examples. We have print, and in parentheses we have a comma here, a comma and a space enclosed in your string double quotes. Then you use dot join. So we are going to join each of these list items, and it's a list because it's enclosed in the straight brackets. The list is the word spam, the word eggs, and the word ham. We are going to join each one of these list items with a comma and a space. So the output of that is prints spam, comma, eggs, comma, ham. The next print command, print parentheses, the string hello, me. Now we're using dot replace, and in parentheses after that, we have the string me, comma, the string world. So our output for this, since we're not using join anymore, we are using replace. That's going to print hello world. It was originally hello me, but we swapped me with world. So now you get hello world. The third print command, print parentheses the string. This is a sentence dot starts with parentheses the string this. So dot starts with wants to know if what was before it actually starts with this, and it does, because print this is a sentence dot starts with this, you're going to get the output of true. Now we have print parentheses the string this is a sentence period dot ends with the string sentence period. That's also going to give us a true output. The next one, print parentheses the string this is a sentence dot upper, and we have nothing in the parentheses at all. We're just using the method to give everything an uppercase letter, and it's going to print this is a sentence all in uppercase. Whereas print an all caps sentence dot lower will print an all caps sentence. So it's basically doing the opposite of what upper does. Lastly, we have print parentheses spam comma eggs comma ham dot split. What are we going to split? We are splitting the comma and our output is going to be the list spam comma eggs comma ham. Okay, that's a little confusing, but I gotta move on. Fill in the blanks to turn the string uppercase. Okay, so on the right of the equals, we have the string spam, and we're going to put that into the variable called a. And we want to turn the value of spam, which we're using a with uppercase. So b equals a dot upper. A dot upper is going to change SPAM to capital S, capital P, capital A, capital M. To find the maximum or minimum of some numbers or a list, you can use max or min. To find the distance of a number from 0, which is its absolute value, use abs, which is short for absolute value. To round a number to a certain number of decimal places, use round. And to find the total of a list, use sum. So here's some examples. Print parentheses min parentheses 1234021. Your output will be 0 because it's looking for the minimum value of all of those items. And those items, because they are in parentheses, I believe we would call those tuple items. The next one, print max, we have parentheses, and then we also have square brackets, so now we're talking about a list. The maximum list item in this 1492568 is 8. 8. 9. It's not in any kind of order. So the maximum output is 9, and that's what you see on the next result line. Then print parentheses abs parentheses negative 99. The absolute value is 99. Whether it's on the negative value or positive value, the absolute value is still how many spaces away from 0 is it? It's 99 spaces away from 0, just in the other direction. Next we have print parentheses abs parentheses 42. The absolute value of 42 is 42. The absolute value of negative 99 is 99. The absolute value of 42 is 42. Like I said, It is how many characters or how many digits away from 0, whether it's to the left of the 0 or the right to the 0. Absolute value does not matter. You never have a negative absolute value for something. The absolute value of -3 is 3. The absolute value of -99 is 99. The absolute value of -4 is 4. All right, lastly, print, parentheses, sum, parentheses, the list. So you have parentheses and square brackets, 1, 2, 3, 4, 5. We will add each one of those list items, 1 to 2, which is 3, 3 to 3, which is 6, 6 to 4, which is 10, and 10 with 5, which is 15. So that's why you see in the result, the very last value that's output is 15. What is the result of this code? All right. This is nice and long. We have A equals min, parentheses, and then we have a list. We have a list that goes all the way from the opening straight bracket with the word sum all the way to the end, the ending straight bracket and the closing parenthesis, right before you see the command print parentheses A. So that whole list is separated by a comma. So there's two list items here. The first one, see, now we're working on the innermost things, and then we're going to move out. So we have sum, parentheses, the list 11, comma 22. What is the value of sum, the list 11, comma 22? We're adding 11 and 22, so it's 33. So sum 11, 22 is 33. Then we have a comma and the max. So now we're looking for the maximum of two numbers. Absolute value of -30, which is 30, comma 2. What's the maximum number, 30 or 2? It's 30. So max abs -30, comma 2, value of that is 30. The sum of 11, 22 is 33. And let's spread out a little more to our minimum keyword. So we want to know what's the minimum of 33 and 30. It's 30. So the entire value of A should be 30. So when we use our print command, print A, we should have 30 as the output. And it is. Often used in conditional statements, all and any take a list as an argument and return true if all or any respectively of their arguments evaluate to true and false otherwise. The function enumerate can be used to iterate through the values and indices of a list simultaneously. Okay, for example, here we have a list called nums. Nums equals square brackets 55, 44, 33, 22, 11. If all, and then in parentheses we have one of those, I forgot the name of it, conditional lists. That's not what it's called, but anyway, I greater than 5 for I in nums. Okay. If all, I greater than 5 for I in nums. For I in nums, for item in nums, nums has 55, 44, 33, 22, and 11. If every single one of those items is greater than 5, then you will print the string all larger than 5. Well, 55 is greater than 5, 44 is greater than 5, 33 is greater than 5, 22 is greater than 5, and 11 is greater than 5. So that if all is true statement, because the condition is true for each and every single one of those list items, which is represented by I. So we will see the output print all larger than 5. So you look down to the result, you can see the very first line of output is the string all larger than 5. Now let's look at the next statement. If any. Okay, so now we're not looking for every single item in the list to match this condition. We just want one of them. We just want any, just one. And here's the condition. If I modulo 2 equals 0, so what we're asking for is if the item is divisible by 2 with no remainder, which means is it an even number for I in nums, then we will print at least 1 is even. Well, 22 is even, 44 is even, so we're good to go there. The if any condition works. So we will print the statement at least 1 is even. And if you look down at the result, the very next line does say at least 1 is even. Lastly, we have for v in enumerate parentheses nums, colon, print v. Okay, so the function enumerate is going to iterate through the values and indices simultaneously. So we're going to see the values and indices. For v in enumerate nums, print v. 55 is the value, 0 is the index. Nums 0 has a value of 55. So for v in enumerate parentheses nums, print v, start off with the index, which is 0, 0 comma 55, 1 comma 44, 2 comma 33, 3 comma 22, and 4 comma 11. 0, 1, 2, 3, and 4 are all the indexes, and 55, 44, 33, 22, and 11 are the values. Simultaneous index and value. So enumerate is a good function to learn. What is the result of this code? Here we have a list because it's in square brackets. The list has a name of nums. Nums equals square brackets -1, 2, -3, 4, -5. If all, so every single one of those list items, -1, 2, 3, -1, 2, -3, 4, -5, every single one of those has to follow whatever this condition is. Now, inside of the parentheses, we have a list because you see the square brackets. Abs, parentheses I, less than 3 for I and nums. Okay, for I and nums means it's a for loop, and it's iterating through each one of these list items in the list with the name of nums. Okay, so for I and nums, we have to figure out what the left-hand side of this means. Abs I less than 3. Absolute value of I less than 3. All right, let's look at each one of the list items, starting from left to right. The absolute value of the first I is nums index 0, which is -1. Absolute value of -1 is 1. Is 1 less than 3? Yes. Let's go to the next one. The absolute value of 2. Because now we're looking at nums with the index of 1, which has a value of 2. The absolute value of 2 is 2. Is 2 less than 3? Yes. Now, moving on to the next list item. Is the absolute value of -3 less than 3? No, it's not. Because the absolute value of -3 is 3. 3 is not less than 3. So now we found something that does not give us all. Therefore, we will not print 1. We will bounce down to the else, and we will print 2. Because if all means all or it's false. Okay. Text analyzer. This is an example project showing a program that analyzes a sample file to find what percentage of the text each character occupies. This section shows how a file could be opened and read. Okay, so on the right-hand side of the equals, we have input, parentheses the string, enter a file name. Okay. And then on the left-hand side of the equals, we have the variable called file name. Now we're using a with statement. With open, parentheses, file name as f, colon, text equals f dot read. Then finally we print text. So we're opening whatever the user types in for a file name. Let's just say they type in file.txt. Whatever they type in, or if they have a file called Apple, and then they type in Apple, input is gonna take that value that they typed in, which is Apple or apple.txt, and they're going to set that to the variable called file name. Okay, so then when we say with open file name is representing whatever the user typed in. And when we use as f, now we're making things even more simple by giving the variable file name an even shorter alias called f. So now we're going to use f to represent file name, which represents whatever the user typed in the file name to be. So on the right hand side of the equals, we have f.read. Okay, so that's something we're commanding it to do. And then we're setting whatever that value is to a new variable called text. So finally, when we use the print command and we print the variable text, here's our result. First, you get the input enter a file name line with a colon, and the user typed in test.txt. Test.txt went into the variable called file name. Then with open file name, it means open test.txt as f. So then f.read is really test.txt.read, and then that's going into this name text, and then print text prints out whatever the value of test.txt is. So really, it's just taking the name of something and putting it into one variable, doing something with that variable, giving it an alias to use in another line, and then using another variable to be used with the print command. So it's just name swapping. You just have to pay attention to the order of operations here. But as you can see, whatever this fake test.txt file is, all this mishmash baloney that output, this is just an example of what test.txt could actually have. This is a sample content for demonstration purposes only. Fill in the blanks to read the contents of a file using the with statement. So, with open parentheses file name as f, colon, text.f.read. This part of the program shows a function that counts how many times a character occurs in a string. So let's look at this function. Def, you have to use the def keyword because we're defining a function. Def, the name of the function, count underscore char, which is short for count characters. And then in parentheses we have text, comma, char, colon. The next line, we have a variable called count, and we set it to an initial value of 0. Count equals 0. Now, for C in text, colon, if C double equals char, colon, count plus equals 1. So count is going to start at 0, but then it's going to bump up to 1 in the for loop, as long as C is equal to char, and it's going to keep looping from 0 to 1 to 2 and so on and so forth. And then finally we have the statement return count. This function takes as its argument the text of the file and one character, returning the number of times that character appears in the text. Now we can call it for our file. So on the right hand side again we have input and then in parentheses the string enter a file name. So if you look down in the result you see enter a file name and a colon. That test.txt is what the user types in. The code doesn't output that. You type that in as a user. Then we use the with open parentheses file name as f colon text equals f.read. So we're reading the file, we're reading the file and putting it into text. Then we're using the print command parentheses count underscore char, which is the name of that method, that function that we created at the top. And that function count underscore char had two parameters in its parentheses, text, comma, and char, which down here we are going to replace with text, comma, r. Okay. So it is going to look for the letter R, and it's going to count how many times the letter R is in the file. And here, it's giving us an output of 83. The character R appears 83 times in the file. Why has the character counting code been put in a function? Well, so it can be run multiple times. I'm going to run this function, as many times as you want with maybe different letters or whatever. The next part of the program finds what percentage of the text each character of the alphabet occupies. So here we've got a for loop. For char in this long string, which is just the alphabet, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, colon. Perc, which is short for percent, equals 100 times count underscore char, parentheses text, comma, char, divided by len, parentheses text. Len is used for length, okay? And lastly, we have print, and in parentheses, we've got that formatting thing. In the string, we have placeholder 0 dash placeholder 1% dot format parentheses char comma round parentheses perc comma 2. And then you close up all of those parentheses. Let's put it all together and run the program. So here again is our count char function. Def count underscore char, and we have two parameters in the parentheses, text, comma, char, colon. Count equals 0 for C in text. If C is equal to char, colon, count plus equals 1, return count. The next little section we have is file name equals input, parentheses, the string enter a file name. With open parentheses file name is f, colon, text equals f.read. Lastly, we have for char in the string A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, colon, per, short for percent, equals 100 times count underscore char, parentheses, text, comma, char, divided by len, parentheses, text. Finally, print, parentheses, the string placeholder 0 dash placeholder 1% dot format parentheses char comma round parentheses perc comma 2. Here's the result. You see, enter a file name, then the user types in whatever the file name is. In this case, the example is test.txt. The very first line of code is the letter A with a dash and a percent, 4.68%. The next line is the letter B and a dash with the percent that letter was in, 4.94%. Then you have the letter C dash 2.28%, and so on and so forth. So this is supposed to represent how many times a certain letter was in text.test. Not how many times each letter was in A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. No. We want to know how many times it's in that file. The file test.txt. So if you've got like 3 different test files, test1.txt, test2.txt, test3.txt, and you run this for each one of them, you're going to get the alphabetic percentage of A, B, C, and so on and so forth. It's going to be different for each file, provided that each file is different. What is the purpose of the round function in the code? To reduce the number of digits printed. Because you could have a digit with 13 decimal places. You just want to round it because you don't want to deal with all those decimal places. So you want to reduce the number of digits printed. All right, now we're on to Module 5 quiz. Can you slice a tuple? Yes, you can. Which list slicing reverses the list numbers? That would be numbers, and our range would be : -1, which means from the beginning to the end, starting at the end. There we go. What could be described as an immutable list? A tuple. Can't change those list items. What is returned by functions that don't have a return statement? What is returned by functions that don't have a return statement? None? Okay. Without a return statement, I guess there's an absence of value, and an absence of value gives us the output of none. Okay. What is the result of this code? We're looking at a tuple because what's on the right-hand side of the equals is in parentheses, so we're looking at a tuple, and the name of the tuple is nums, and we are going to print the maximum of 2 things: min nums 2 and abs -42. All right, we want to find out what the maximum of each one of those, but we've got to figure out what the values of them are first. Abs -42 is easy enough because the absolute value of -42 is 42. So the value of abs -42 is 42. So think of a 42 there. The next thing we want is let's see. The minimum of nums starting from the beginning of the list to the starting at nums index 0 up to nums index 2, but not including index 2. Nums index 1 is 55. Nums index 0 is 55. Nums index 1 is 44. Nums index 2 is 33. We do not want to go that high. So we want to know what's the minimum between the numbers before that, which were 55 and 44. The minimum of those two is 44. So that value is 44. So we want the maximum of 44 and 42. That's 44. And we want to print that. So there we go. Okay, and that completed the Python 3 More Types tutorial.